All right, so we are in AP Calculus. Today's date is Thursday, January 23rd, 2020. Understanding total change. So yesterday was just talking about rates. Today is talking about total change. Again, we're using integrals and we're applying it to real world problems. Anyone want to read our objective from today? Sego, yes, thank you.
Use both positive and negative equations to answer questions about.
Yeah, it's almost the exact same thing as yesterday. The only difference is this word. It used to be about rates. Now it's about change. All right, so we have the same exact problem, and I did fix this so it looks nicer. It's actually showing up the same exact problem. We have 60-day periods. There's a cylindrical can out there, and it's filling up. So its height is given by, or the rate of the height is given by this function. Are there questions about the original problem? We're good. All right, so let's look at a graph of what's happening. This is the exact function s prime of t graphed out for you, and you can see it's over a 60-day period. So it looks like maybe between here and, well, I don't know where it happened, maybe right there and there, it stopped raining and maybe started evaporating. The height started going down, so we can kind of interpret the graph on what's going on. Oh wait, that's not true. This is a rate, isn't it? So it's actually, the rate is still positive. The rate is above the t-axis. It's just the rain has finally started slowing down at this point. Okay, so I've talked about this before. I'm going to talk about it again. What's happening when we take the integral in terms of our units? So what is our y-axis? Quiet raised hand. Y-axis. What are our units? Geo.
Days?
Careful. Days is this one.
And the other one's millimeters.
Millimeters, perfect. So we know that units, we have a height of millimeters, and that's 60 days on our t-axis. So again, whenever you're taking the integral, you want to be thinking of an infinite number of infinitely thin rectangles. Let's go ahead and pull out one of those rectangles to analyze what's going on. Let's change this to a black outline, no inside. All right, so I have a rectangle. You're drawing your own rectangle. In terms of the units of this rectangle, we know that the bottom has units of days, so we'll write down days down here. And what is, we have to be careful. This is actually not millimeters, is it? Because this is a function not of height, but of rate. This, yeah, it's actually millimeters per day for this graph. So over here, I'm going to do millimeters per day. And if I multiply these two units together, you say, okay, for our units, we're going to have millimeters per day. And I multiply by days. And then notice that the days cross cancel, and I'm just left with millimeters. So each of these units is millimeters. So whenever I take the integral of the rate, I'm left with millimeters. And that makes sense. If you take the integral of velocity, you get position. You get rid of the denominators, units, days, and it just turns into millimeters. We've seen that before. Everyone is roughly comfortable with this. The whole idea of this course is I kind of repeat the same information over and over. So if this sounds familiar, that's great that you remember that. All right, let's move on. So we need to explain what this means in terms of the context of the problem. So, what am I talking about here? Quiet raised hand, who wants to take a shot at it? Yeah, Gio.
The amount of the amount of like water of how much is filled up through 30 days.
Yeah, it's the amount of water, or the total change in water, because maybe there was already water in there to begin with, and we don't know that. Maybe we had an inch of rain in there already, or 1 millimeter of rain in there already. So you have to only think of this as the total change. So I'll type in our answer here. And I need to make this size 18 so I can see what's going on here. And this is going to be the total change in the height of the water. Okay, what are our units in change in the height of the water? And this is where you have to be really careful. This whole unit, unit 8, is very tricky with its units. So if I'm talking about the height of the water, or the change in the height of the water, should it be millimeters or millimeters per day?
Millimeters per day. Millimeters.
Okay, two different parties. You can either rock, paper, scissors, or maybe use some logic.
Because it's just asking about the height. It's not asking about the rate. It's asking about the height. Change?
He's asking the change in the height, so it's from this point to this point, how much is
I realized I have no idea which question we're answering.
Question A right now. What are
Total
units?
Change in the height of the water.
Sego Geo, weigh in. Is it millimeters or millimeters per day?
Millimeters per day.
I think so too. I don't know why. I think so.
So it is actually just in millimeters in this
Oh,
one.
really?
Yeah, it's the height of the water. So when I talked about the total change, I said I have a total of, I don't know, 5 apples, the total amount of things. I don't care about how long it took to grow those apples, or how long it took to eat those apples, or how long it took to have a change in the height of water. I don't care about time. This question has no terms of time in it. Although it does tell you the time over here from 0 to 30. In terms of just the total change, I don't care about time, so it's just an amount. So over here we're going to say total change in millimeters from 0 to 30, and then what are units for 0 to 30? Shout it out.
Millimeters.
0 to 30
What?
days.
Oh my god. I'm still-
Unit of time, yeah. All right, so the general rule of thumb here to try to get that point, and it's only 1 point if you get all the units correct for every single part of the question, generally speaking, is whenever you have total change, and I'm going to underline that, total change that pairs with an amount. That is an amount. That's why we have in millimeters. Okay, let's try to do part B. How many millimeters has the height of water increased? And this is where we pull out our calculators. So I'm actually going to pull out this thing. I'm going to say, yes, we're going to find the integral from 0 to 30 of s prime of t dt. And we calculate that. So let me pull up my calculator as well.
Do we go to what? Yeah.
Yeah, you probably have it from yesterday, maybe. Oh, maybe not if you did all the homework on. So 2 sine of 0.03 t, and x in this case, and then quit out of it. And then we need to take the integral. So that's going to be a math 9. So
Wait, so we. Oh, okay.
math 9, var is right, and to enter y1 with respect to x from 0 to 30. Let that calculate it. I'll come over here in our notes. I'm going to write the note. If you're ever doing the integral, it's always going to be the math button and then 9. Every single time. Math 9. And I got 25.226. So 25.226. And now the question is, what are our units?
Millimeters.
Millimeters. Yeah, it's the same thing that I was talking about up here. Millimeters. That's a bad M. There you go. All right. Any questions on part B? I feel like we've done this before because we have. Now we're just applying it to problems now. All right. We have exactly the same rates as before with an amusement park between 9 a.m. and 11 o'clock p.m. Let's answer the following questions. We should probably program both of these in our calculator. Again, whenever it gives you a positive rate, this is a positive rate because
I
it's...
the positive rate.
Someone else answer. Why is that a positive rate?
If you read the thing like just above it, it says the rate which we will enter, and entering is positive, the other one says leave.
Enter and leave. Yeah, thank you, Arrow. So this one is going to be a negative rate. Oh my gosh, what is going on over there? So immediately plug in both of these into our calculator. So I come over here and I say my y1, let's get rid of you. Let's say that you're 8600 divided by the whole quantity. Keep your parentheses for the denominator since I have multiple terms. T squared minus 25 t plus 163 and your parentheses, and 9890 divided by in parentheses t squared minus 38 t plus 370. And what's the unique thing whenever you have a positive and a negative rate?
Subtract from each other.
Yeah, you do the positive rate
Minus
minus the negative rate. Yeah, so let's go ahead and say which one is positive. It's the E1, so our Y1. So var is right, enter 1, our Y1 minus var is right, enter 2. So your third function, which is your kind of your all function. It encompasses both your rates. Is going to be your positive rate minus your negative rate.
I feel like this is the exact same questions and problems we did.
Yeah, they're very, very similar. One's talking about rates, one's talking about total change. This is the number of people instead of how fast those people are entering or leaving. And it's really cool to be able to compare these notes to our previous notes to see how they compare and contrast. All right, so we have our functions in. Do I need to give any more time? No, Sego, you're good? All right, so let's go ahead and answer part A. How many people entered the park during the first 4 hours? What is it really asking for? What math equation is it asking for? With a quiet raised hand, Gio.
Plug in 4.
Say again?
I just plug in 4.
We don't. If we plug in 4, that would be the rate at which people enter. I'm looking for the number of people. How many people?
We found an interval between 1 and 4.
Between. So it opens at midnight. Midnight is going to be 0. So between 0 and 4 of what? Of which function? E, L, or this third function?
E.
Why E?
Yeah.
Yeah, because it's entry. Perfect. Let's go ahead and do that on our calculators. See if we can all get the same answer. So I'm going to do second mode to quit out of this. I'm going to get rid of that. Math 9 to do integral. Var is right, enter, enter. Y1 with respect to x from 0 to 4. Ooh, syntax error. What did I do? Is it somewhere in there? Oh, I typed in a square there. It should have been a t squared. So second insert x squared. And now, if I do this, let's try entering that again. I get 303.571. Is that
Well,
what?
we rounded because that's people. So 304 people.
Yeah, this is going to be a little bit different. This is going to be, and yeah, it makes sense to round up the first 4 hours. Yeah, let's round up in this case. So always round to the nearest whole number. So we'll put a very big note here. Round to the nearest whole person. Because now we cannot, like rates are okay because that actually makes sense. Now we're talking about the number of people we have to do. So I'll say that the integral is 303.571. 303.571. But that's going to turn into 304, and I'll do the units people. And I can box that one. 304. And how many people leave the park during the first 4 hours? So, Stego, what am I going to be doing now? DT, perfect. And I'll let everyone keep calculating these. So I'm going to do second enter, and then all I have to change here is my Y1 to second, or not second, just var's right, enter 2. And I replace that, and I got 134.483.
135.
Yeah, 135.
Wait, wouldn't it be 134?
For, oh, we'd round down in this case, yeah, because it's 0.4. 134.483. 483. So that's going to turn into 134 people. And part C, what is the total change in the number of people during the first 4 hours? What am I going to do in this case, Claire?
The integral from 0 to 4 of E of t minus L of t.
There's E of t minus L of t, and then all of that thing times dt. So that's going to be my same thing, except I'm going to enter y3 in this case. Var is right, enter 3. Oh, var is right, enter 3. Then hit enter. And I can just subtract those two, but I get 169. 169.087. 08, I guess 8. And that turns into 169 people.
So on the test, should we write the unrounded number and the rounded number?
If you write the rounded number, you'll get the points. They don't really care if you do the unrounded number.
Okay.
Cool. And that's all I've got for you guys. Any questions? Cool. Let's do the homework.